Hi again, and welcome back to my YouTube channel. I'm going to begin a series of number presentations related to systems engineering measurement. I will tie in requirements in this as one example of system engineering measurement, measuring requirements, quality, and related things. I got involved with systems engineering measurement in the mid 2000s because I asked a question during our system engineering process definition activities, and people were saying, well, we want to measure this and we want to measure that. And I started asking about, well, why don't we systems engineer our systems engineering measurement? And that, of course, got some chuckles because people recognize that systems engineers don't always use systems engineering for their own work. So that got me stuck with responsibility for leading our Boeing Defense work on systems engineering measurement. This paper was developed in 2007, 2008, based on that activity, and my colleague Boyan Zlicherich helped me with the requirements quality activity measurements. He's currently at Blue Origin, as I recall. So, using performance-based earned value for measuring systems engineering effectiveness. I'm going to talk about performance-based earned value, contrast that with what you may recognize as earned value management. Talk about system engineering effectiveness, system engineering metrics architecture that we came up with to support system engineering effectiveness, and some example metrics for requirements. To start with, this is the first figure in the written paper, which is available in the Wiley and Cosi presentation library. This was a paper from 2008 symposium. Using measurement as part of a closed loop feedback control system. And this version of this figure actually made it into the Nkosi measurement primer, the 2010 update, based on my input. So we use output measures to control the process application. In other words, we measure what we are doing based on the product that we're producing and use that to control the process application. So a lot of people worry about process metrics, but really the more important thing is to focus on product metrics. And I'll be talking about this in the next couple of presentations about correlating product and process measurement. But if we don't have a closed loop feedback control system, we're measuring things without knowing what we're doing with the information. And the ISO standard and the Nkosi measurement material all point to the need to be using measurement to make decisions. So we make measurements, we control what we're doing, and then we make decisions to change what we are doing to hopefully improve the quality or other measurement regarding our output work products. Focusing on process measures can help us diagnose product nonconformance, but the primary measurements we should be using are measurements of product quality, throughput, and so forth. If you look at the earned value standard, this is ANSI EIA 748B, earned value is a direct measurement of the quantity of work accomplished. That's what the standard says. It says the quality and technical content of work performed is controlled by other processes, and that's my emphasis added. So we need some other method to assess the quality of the work accomplished. And this was first pointed out to me by Paul Solomon and Ralph Young's book about performance-based earned value that they published about this time, to point out that earned value management was insufficient or inadequate for what we really need to care about in terms of getting work accomplished and reducing or eliminating rework. So we need some other method to assess the quality of the work accomplished, not just the quantity. So example I used to use in one of my graduate classes to illustrate what performance-based earned value really means is washing windows. And if you've raised children, this is a common household job that we had our children use, and I had it when I was growing up, to earn extra money. So clean the windows. That's the desired outcome, is we have clean windows. We didn't get into the specifics at the time, but when you think about what you're after, the quality measure is that I can't see anything on the window surface. There's no distortion or obscuration when I'm looking through it or in the reflections. That's what we really mean when we talk about a clean window. There's nothing left on the surface. So earned value management would say, I executed the process and I washed the window. And so I know I earned the value because I washed the window. Performance-based earned value adds the additional stricture that the window is clean. So if the parent responds to the child after the child says, I washed the window, the parent says it's not clean. So did the child actually earn the earned value? Well, according to the earned value standard, yes, they executed the process and they washed the window, but we didn't get what we wanted, which is a clean window. In other words, we failed to satisfy the quality measure. So we say it's not clean, and the performance-based earned value is much less than the earned value actually, because it's not clean. We're missing the quality attribute. So unearned value is really the cost of the rework. I have to go back and wash it again. Maybe I'll use a slightly different process. Maybe I need to get out the razor blade and scrape stuff. Maybe I need to scrub in a particular area. Whatever it is, I failed to satisfy the quality criteria, so I have rework. And earned value doesn't easily account for that rework based on quality failures. Somehow it'll get tracked, it'll get worked later in the project, maybe a new cost account, but it's hard to track this because we haven't included the quality measure on the work product. And that unearned value is the cost of rework. And if I just do the job the way it was defined, but I don't achieve the quality attribute, then I'm going to be left with rework. And this is something that earned value management, according to the standard, doesn't handle well. So what do we mean by quality? Well, there's lots of definitions. The one I like is by Crosby, quality is free, from 1979. Quality is conformance to requirements. Therefore, the quality of work accomplished is composed of two parts. One is the inherent quality of the work product in conforming to work product standards. So could be requirements, specifications, drawings, plans, reports. We have templates and standards for those things. That's one aspect of quality. And then the other aspect is conformance of the work product to technical requirements associated with the system we're considering. For example, you may have good design representation, first attribute here, but does the design actually enable you to satisfy all the requirements? So that's the second part of the quality characteristic, conformance to work product standards. So you have to define those, and I will get into those in my 2011 paper, but also conformance of the work product to the technical requirements associated with the system, beyond simply conformance to generic work product standards. So for example, when we talk about specifications, which I treat as collections of requirements, all the requirements for a system of interest, then quality is represented in two parts. One is the specification structure and the syntax of the requirements. So as regard the specification, do we have the right outline? And as regards the requirements, do they conform to a template standard, a pattern, if you will, according to the latest INCOSE Guide to Writing Requirements? So do I have all the necessary types of requirements listed? Is the document formatted properly? Second, are the requirements themselves well stated? This gets into the quality of the requirements. We start with the idea of verifiability. If it's ambiguous, then it's not going to be verifiable, and there's a whole bunch of criteria in the NCOSE Guide to Writing Requirements, and we of course have published material on this as well. And then there's the specification content. The content of the collection of requirements and the content of the individual requirements collectively, are they going to enable the system of interest to satisfy the user needs? So this is really about the validation question. And so I focus on that in a later paper, the 2018 presentation on formalizing requirements verification and validation. So this is an earlier paper, one of my first ones on system engineering measurement, but we recognize that there are two parts. One is conformance to standards, and the other is about the content. Is it going to enable us to satisfy the needs and measures of effectiveness on behalf of the user and other stakeholders? So we considered the idea of systems engineering effectiveness as our top level criterion for what we ought to be achieving with systems engineering measurement. That is, an ability to produce the needed result using the committed resources. So if we're more effective, then we either exceed the minimum requirements or we're more efficient in the use of resources. So resource commitments are going to be based on planning, and then earned value management measures execution versus the plan in terms of resource utilization. Beyond that, however, from a system engineering perspective, we need not just effective resource utilization according to good plans, but we have specific work products and related program outcomes, not just about cost and schedule, but about technical performance. That is, we have systems that satisfy requirements and needs. And I was embarking on this, and one of my managers kindly pointed out to me some presentation work by Paul Solomon, and I subsequently obtained the book by Solomon and Young on performance-based earned value. So I'm indebted to them for this concept. What we did was we defined system effectiveness, and then we began decomposing it according to these contributors, and constructed from that a systems engineering metrics architecture that then guided the rest of our systems engineering measurement work in the Boeing Company for the next few years. And that included discussions about product quality, that the work product and the system of interest satisfy the needs and requirements. And then cost and schedule are collectively measured by earned value, but we also need to be measuring the effectiveness of the planning itself. Is it a good plan? Is it well defined, and so forth? Because planning is the basis for measuring earned value. And earned value doesn't actually measure whether your plan is any good. It just says, are you working to plan in terms of budget and schedule? So the essential elements here are work product quality and completeness, the fitness for use by whomever the downstream customer is. They get to define whether it's going to be adequate. And then the timeliness. Is it available when it's needed? And that's defined by some coordinated schedule and measured by earned value. And also we have the resource utilization. So when we look at the NCOSE system engineering leading indicators, they are primarily focused on process measures and trends. And in my mind, there wasn't enough attention to actually measuring work products and outcomes. So that was what I focused on in this work. So the top level of our system engineering measurement architecture began with a box I called system engineering effectiveness. And then upon learning about performance-based earned value, I included that up here as well. And that's decomposed in two primary parts. One is about the product quality, that the product satisfies the need. That's the validation question. And then the resource utilization, earned value, which is cost and schedule versus a plan. And that means we have to, contributors to that are going to be the planning, the integrated master plan and the measurements associated with that, measurements of cycle time, and measurements of resource utilization versus the plan. On the product quality side, which was much more interesting from my perspective, we decompose this validation question into two parts. One is that the product complies with requirements, but the second part is that the requirements actually satisfy the need. Again, the validation question. So 1.1 here is related to verification, and 1.2 is related to the validation question. And again, we revisited this in the 2018 paper when I went into this in verification and validation in much more detail with respect to requirements. So if we use performance-based earned value for systems engineering effectiveness, then we need to define the work in the integrated master plan, integrated master schedule, identify and define the work products for every scheduled activity. What's the evidence of completion? So I can't sufficiently identify an activity like perform an analysis without also clearly identifying the outcomes. What are the work products associated with that? Are there standards associated, for example, with analysis? Are there necessary plans associated with that? What's the quality of that work product when it's done? In other words, how would I measure fitness for use? So we began investigating and defining objective work quality standards for all work products associated with systems engineering activity, including technical content requirements for the work products. And I go into this in some detail in one of the ongoing presentations in the 2011 INCOSE presentation, which I will put up on the YouTube channel in a few weeks. Our progress assessment is based on earned value management, but we only earn the value if we satisfy the work product quality standard, meaning we satisfy the technical requirements associated with that work product. Solomon's book discusses technical maturity per plan as a percent of technical performance measures achieved. My take on this is we actually really need to be measuring the cost of rework, not just percent of TPMs achieved, but have I actually achieved the quality standard for the work product such that I don't need to redo it? So unearned value, in other words, using the earned value associated with any particular work package, unearned value is the cost of rework, the work not yet accomplished, but will need to be applied in order to produce a work product that satisfies the requirements. Whether it's a design that fails to satisfy its requirements, or requirements that fail to satisfy a need, or verification activity that doesn't produce the information necessary to be able to demonstrate or prove that the system of interest satisfies its requirements. Anytime we have rework, that's unearned value. Formally, it really should be subtracted from any work package where we say, well, we completed the work. We didn't earn the value of that work package if we have rework. Of course, this wasn't very popular with people that wanted to say, well, I finished doing the requirements, or I finished doing the drawings, or I finished writing the software, or I finished doing the testing. And the fact that we need to redo anything, well, that's got to be a new work package. So as much as Paul Solomon tried to get the earned value management people to accept this concept of performance-based earned value and unearned value, I believe he was not ultimately successful, which is unfortunate, but that doesn't mean we can't use this concept of unearned value related to rework to properly hold accountable cost account managers and other workers to make sure that their work products actually satisfy the work product requirements for that work package. So if we decompose the technical compliance of the design with respect to requirements, then we immediately get into decomposition of 1.1, that the system complies with the requirements, and that's composed of measures associated with the requirements themselves. And that was really the first thing we began tackling. What's the quality of the requirements? How do I know I'm not going to have rework associated with them? Then the quality of the design and implementation. Is it going to satisfy the requirements? And then the design analysis and the verification to prove that we actually do have compliance. And in our work at Boeing, we actually began defining measurements associated with each of these elements. Eventually, for example, under the design and implementation, we published some work on architecture measurements, and I'll present that in an ongoing paper on this YouTube channel in the future, so you can watch for that. But one of the first top-level measurement that we proposed was ensuring that the system, at whatever stage of development, is expected to satisfy the requirements. And we recognized that there's immaturity along the way, that at, for example, system requirements review, we have a lot of requirements, and that's the point of that discussion. In this case, we had, so black here indicates known non-compliance. That becomes a program issue at that moment. If the requirement is retained, then you've got to go do something to evolve the system concept to ensure that it does become compliant at some point in the future. We may have unknown compliance. There's requirements that we've not evaluated with respect to compliance, and that represents some degree of risk. So a non-compliance is an issue. Unknown compliance is a risk. And then we have 3 levels of compliance with different assessments of risk. So high risk, moderate risk, low risk, and then ultimately, once we start performing verification, we effectively reduce the risk dramatically. So you might say we've eliminated it. Maybe not going to go that far at this moment, but it's verified. And as we have the evidence to demonstrate, prove that the system of interest satisfies one or more particular requirements. The purple line just indicates that over time, the number of requirements expands as we go from system requirements, system concept, to system architecture and all the subordinate elements. So that means at preliminary design review, for example, you have all the lower level specifications and their associated requirements. And that's a reason why the number of requirements would jump dramatically during the evolution of a project. So in my mind, this is probably one of the most important measures to apply to any system of interest. And we included this in COSI measurement working group work product called Project Manager's Guide to Systems Engineering Measurement for Project Success. And this was one of the key technical measures that we suggested project managers should be applying. The other one, and this is where we started doing more detailed work with our projects, was what we call the requirements quality assessment or requirements quality measurement. And I talk about this one in the 2015 paper that's available on the YouTube channel, implementing structured requirements to improve requirements quality. We started measuring, and we used a graded scale based on the structure of the requirement with respect to the template standard and what we expected in each element. For example, I will regularly refer to the need for observable functions, because if you don't have observable functions, then you probably don't have a verifiable requirement because you don't know where to go observe it. So when we have functional performance requirements, they need to have observable functions, which means each requirement needs to be tied to some interface. Those are some of the common criteria we applied. And we put a graded scale that out of a scale of 0 to 4, anything above 3, you're doing pretty good. We colored that green, and that was our target for most projects because most of them were running in the area of 2 at best. So we had one program assessed over time, different specifications being evaluated, and then a number of several programs that we evaluated over that same period. And you can see the scores sort of are around the 2 area, and no particular trends. We hadn't attempted to focus their attention on means to improve their scores. We were in the process of measurement. The closed loop feedback control was coming, but these were some of our initial measurements to begin having an objective standard for the quality of specific requirements on a program or all the programs in our particular division. So this is how we got started implementing system engineering measurement to improve the quality of our systems engineering work. So, summary, earned value alone is inadequate to assess the technical progress, and it says so right in their standard. Program goals include satisfying cost, schedule, and technical requirements. That's part of what systems engineering is trying to help with. We learned that performance-based earned value offers a method to integrate these, and by measuring the cost of rework, we can determine the unearned value even for work that is ostensibly complete. Finally, the architecture of system engineering measures enables the decomposition and allocation of the contributors to performance-based earned value so that we can measure all of the common system engineering work products. And I will get into this some more in the presentation of the 2011 paper that I will post up on the YouTube channel in the next few weeks. So thank you for your attention, and I appreciate your subscribing or listening to these YouTube presentations. I look forward to talking to you in the future. Thank you very much.